Okay, Nick here, and I've come out with another video. This one I'm calling Rotating Sphere Earth versus Line of Sight to the Horizon Part 4 East. Okay, and just really quick, over there is the sun. Okay, and it's 93 million miles away from Earth. And over here I have the rotating sphere Earth, showing you the daylight and the night, okay, side of the Earth. And over there is the moon. It's 239,000 miles away from Earth, and it's also showing the light side of the moon and the dark side of the moon. Now, if you notice, okay, both sides of the Earth that are lit up, okay, are pointing towards the sun. The sun is what gives us our light, and it also is what gives the moon its light. The moon is not self-luminous. Half the moon is always lit up by the sun, just as the Earth is always lit up, half of it by the sun. Okay, now over here we have you looking east. Okay, we're gonna see that this is you. This is you right here. Okay, that representing that little dot right there. Okay, in line with the sun. Okay, it's in nighttime. Okay, so it's nighttime. Okay, and this is your line of sight if you're looking east. Okay, line of sight looking east. Okay, now I want to start off this video a little bit different with the challenge to flat earthers. Okay, the reason why you cannot see the sun while you're in this nighttime hours is because the Earth would be blocking your light to the sun. You can't see the sun. You can't zoom back into the sun no matter how hard you try. All right, you can't do it. So the challenge is to any flat earther is at midnight, with the best optics you can give us, is take a picture or zoom back in on the sun at midnight. Just at midnight. Timestamp it, whatever you have to do. Okay, because you don't have an Earth blocking your line of sight to the sun. Okay, you don't have anything blocking your light to the sun. Okay, what you tell us is that there's somehow some kind of atmosphere in the way that stops you from seeing the lit side or the sun, the lit side of your flat Earth. If this was flat Earth, okay, that would be the ice ring. Okay, this would be the equator, and the equator from one point to the other point is only 8,000 miles away. Answer this second question. Why is it that I can see stars that are much farther away and smaller and don't emit as much light? Okay. But 4,000 to 5,000, 4,000 miles away, just 4,000 miles away, I lose sight of the sun. Okay. So that's question number 2. Okay. Now, that's with flat Earth numbers. But this is a globe Earth, and that's representing north. That's representing you, this point here, and your line of sight. Now, I'm going to show you, okay, how the line of sight to the sun, okay, works. Okay, it's based on rotating Earth, and this is why we see a sunrise, because of rotating Earth. Right now, the Earth is blocking that sun. So when I start moving my line of sight, okay, I start moving my line of sight, you can see it. It's moving. You're moving too. You're moving towards the sun. You're moving towards the sun. Okay? And when you look at the sun, okay, the line of sight's there. First, you can't see it because the earth is still blocking your line of sight to the sun. But as the earth turns, you start to see the sun, and just in a couple of minutes, the sun appears on the horizon. Okay, that's easy because you're turning towards the sun. So now your line of sight, okay, your line of sight is now showing you have nothing blocking your line of sight. The earth is no longer blocking your sight. And look where you're at. Okay, right there. Okay. All right, right there. You're just between it's just after dawn. You can see the sun and you're in the daylight areas. All right. So have a wondrous 2025 trying to figure that out.